Good day, everyone. My name is John Jericho Arjose from BIT2K, here to explain to you things you need to know about variable valve timing. But first, what is variable valve timing? In internal combustion engines, variable valve timing is the process of altering the timing of a valve lift event and is often used to improve performance, fuel economy, or emissions. It is increasingly being used in combustion with variable valve lift systems. Some engines have variable valve timing in such an engine that ECU the time controls the time in the engine cycle at which the valve opens. Purpose of variable valve timing. Variable valve timing is responsible for controlling three elements of the intake and exhaust valves. It is responsible for valve timing, or when the valves open and close based on the points in the piston's movement. Then there's the duration, which refers to how long the valve remains open or closed. Finally, VVT also affects the valve lift, which is how far the valve actually opens. In order to monitor all of this, various sensors are responsible for feeding information to the ECU or the computer on board. In addition to sensor, there are physical mechanisms that help control the characteristics and behavior of the valves. The engine needs to monitor the timing in order to handle all the variables of combustion, and without the conventional time scale, you can see just how quickly things actually move when you fire up the engine. When you add in modern electronics, controls to optimize valve events and new fuel injection, it all comes down to precision that can't be more than a millisecond off, or it could ruin the entire engine's operation. Construction of a variable valve timing. So in here you can see the pretty basic construction that I have found on the internet. So in later slides and videos that I will present to you, you will see how this works, but this is the part where oil is flowing. So this gear is connected to the timing belt and this one is connected to the camshaft. Okay, this is the ECU. Oil flows there, go out, it thus goes up or down depending on how the valve is closed or open, and oil passes through here. Cam bearing, unlock position, and there's lock position. There are many types of variable valve timing, but have the same principles, but varies in how they operate. Okay, source, main oil gary. As I've said, oil flows here. So we do have other types of examples, like in here. Uh, Inlet camshaft fluid variator, control housing, and exhaust camshaft fluid variator. Okay, so this is where you've seen in the diagram that the oil flows. Okay, this is the most common one seen in most of cars, most of the cars today that are fuel injected. And usually, sometimes it's only the intake port, intake camshafts that has the variable valve time, and usually this one is the actuator type, which will, I guess, we'll discuss in other videos. So here it is. This is the oil. This is the oil inside. This is the valve that you have seen. Okay. Control pulley, clockwise rotation. So it also depends. I would explain this in the operation. Okay. Scoop, oil pressure, control unit. See, you can see there. I'll also show a diagram of the control unit later on. Okay. So you can screenshot this, you can pause it if you like. This is also a diagram of the name. So this is the actuator. This is the one that is connected to the timing chain. Okay. Stopper pin. This is the one that regulates the flow of oil, if ever, how the control valve needs it. 3 is the camshaft. So here it is. As you can see, it's not connected here in the timing actuator. It's in the center. As you can see here in the diagram, it's disconnected. Number 5, rotor. Okay, rotor. This is where the tire camshaft is connected in the rotor. Okay. 6, housing. The whole big thing that you have seen that houses the rotor and the gear. 7, from valve timing, retard chamber. Okay, retard chamber means to delay the valve from opening and closing, and advancing, as it said, advancing. So there are also a port here where if you need to retard the timing, it would flow in another another valve going to the oil pan again, and this is from the oil pump if you're going to advance it. Okay, and 9 is the spool valve. So there. More of this operations when we get in the operations part. Okay, and here is the control valve. So this is where you plug it in, the ECU, plunger, as you can see, coil. So it's a plunger coil type, spool valve, and this is the parts where it's connected. Here you can see it's the oil drain for retardation of the timing, and oil pressure for the advance. So you can see, as you have seen in the previous slide. So it's a plunger and coil type. Okay, it's electronically controlled. Okay, and this one is what we all know as VTEC. So unlike in the first one, which you can see is just controlling the advance and retardation of the intake, VTEC actually controls more than just that. It also controls the and length and the full opening of the valve, because there, even though it has a time retardation, it can control the maximum opening and closing of the valve. Um, in here, you can see that the VTEX in stage 1 is closed. No oil is flowing. There. That's what it means. This is the rocker arm. And in stage 2, this is where you're about in 300, 400,000 I mean 3,000, 4,000 RPM. So this is around 1 to 3,000, which is this is pressurized oil flowing. Okay, and in the first stage, all this tree is opening and closing the valve. So this one is the smallest. Oops, sorry. This one is the medium, and this is the highest rocker arm. Okay, rocker arm valve cam camshaft. This is the highest camshaft profile. Sorry, these are profiles. These are called profiles. Okay, so in maintaining idle or low RPMs, you only need a small type of cam profile to open and close the valve, so it has minimal air and fuel being sucked in. And in stage 2, this is where mostly we are having higher types of RPM, which we need a slightly higher cam profile, which the oil regulates. As you can see here, as it flows there. And in the stage 3, this is where you're above 4,000 and 7, depending on how many RPMs the engine can do, which is, you can see both of the oil galleys are now open to lock in the third cam profile. Okay, next. Operation of a variable valve timing. The system is comprised of gears that are placed one inside the other, an inner gear that connects to the camshaft and an outer gear that connects to the chain or drive belt. When normal driving conditions are engaged, the cogs are meshed together and turn at the same rate. However, oil pressure makes it easy to separate the gear, allowing them to change their relative speed and help change the speed of the camshaft. Oh, that's not all. I'm going to show you a video that can explain it much better than me. Okay, let me just set it up.
So moving along to the intake side, this, as you can see, just a single cam profile, and what we have here is our variable valve timing. And so if I hold this stationary, and you can see the chain won't move,
and we can advance it or pull timing back and retard the timing.
so as you can see on the intake, there is only one cam profile, and so all we're doing is, let's say, you have your cam profile open, close, you're just shifting when it opens and closes back and forth, and that's all you're doing. The cam profile's remaining exactly the same. So we're going to talk about why you would want to shift when the intake valve opens and closes, but first let's take a look inside and see how this works.
So the variable valve timing is all based on oil pressure. When the profile wants to change one way, the well will fill up here and shift this way. If it needs to shift the other way, there's another port and it'll shift this way. And then when it wants to bleed down the pressure, there's actually a release or a relief hole right down here at the bottom. Then this oil will fall down the timing chain side and it'll reset back to 0.
Cool, so all you're doing, I mean, you've got this little complicated chamber that's sending out oil, and all you're doing is filling either one side with oil or the other side with oil. They both have a port, and then you can drain it out the back there.
That's it. It's all controlled. There's actually, on the timing cover, which goes in front of this, there's a solenoid that goes there. This is a spool valve, like you said, that has different chambers and ways to...
This is the valve that I was talking about. This is the one that controls this to have oil on one or the other type of direction, depending on what the ECU tells the cam profile. I mean the camshaft.
To pass oil through this. There's actually another part to it right here that you guys don't need to know about, so I don't know why I picked it up.
And it's also, probably worth mentioning, the thinking about this gear is remaining stationary. I mean, obviously it's spinning,
right,
but the cam is rotating in relation to it.
The actual shaft is rotating, not the cam gear. So this is more what it would look like if you could get in there and see it in action.
So now we're going to talk about why you want to do...
Next video that we're going to see is the types of variable valve timings.
Car manufacturers have developed a variable cam timing system that adjusts the cam to crankshaft timing depending on change in the engine speed and load. The engine computer plays a vital role in the engine's performance, as it adjusts the camshaft timing depending on the vehicle's engine speed and load. In any range of engine speeds, only one camshaft position in relationship to the crankshaft is optimum for power and economy. Pressurized oil is controlled by the engine computer through an oil control solenoid, which allows engine oil to flow to the cam timing actuator or phaser. As the oil is forced into the actuator, the camshaft timing advances. When the pressure is released, a return spring returns the actuator to standard position, or the actuator is returned by using oil pressure itself, depending on the system. There are three basic variable valve timing systems. One uses a return spring to set the cam sprocket back into its resting position. This system is more primitive and older in nature. The second system uses oil pressure itself to control the position of the cam. This system is now widely used with some variations. It employs a duty cycle controlled solenoid to set the cam sprocket in the desired position. By controlling the duty cycle exactly, the cam sprocket and oil valve is designed to move forward, lock, and backwards depending on duty cycle. In a sense, all the ECM has to do is control the duty cycle in combination with the cam position sensor. The third system is a fully electrical variable cam timing, which uses a brushless electric motor to control cam timing. This system is now adopted on Lexus vehicles. In this video we can see the second, before mentioned, cam timing control system using oil pressure alone. Here's how it works. Variable cam phaser or VCP replaces the standard pulley, sprocket, or gear in a gasoline engine's valve train. It enables the cam lobe timing to crankshaft timing to be changed while the engine is operating, based on the parameters of the engine. This variable cam phasing system includes an oil control solenoid, which controls the flow of oil to advance and retard the camshaft position. The cam angular position, or phase relationship, is controlled by the internal vane mechanism of the sprocket. Commands from the engine control module adjust the position of the oil control valve, which is mounted in the cylinder head, and regulates engine oil flow to either side of the vanes. The oil flow and direction regulation is achieved by modulating the duty cycle to the VCT solenoid. At under 50% duty cycle, the oil flows in one direction, retarding valve timing. At 50% duty cycle, the cam is locked in place. And, at over 50% duty cycle, the cam timing is advanced. Both sides of the control curve, retard and advance, are infinitely variable.
So what it's saying here is just a simple explanation, which 50%, which means there is both oil in the cam on the retard and advance side, is locked, which is the standard position of the camshaft. If it's less than 50%, it means it's retarded. Retarded in time, okay? Less than. And if it's more than 50% of capacity in another side, it means it's in an advanced position.
Variable cam phasing changes the timing of the valve lift event. It can be used to shift the intake cam, or the exhaust cam. This increases engine efficiency, improving idle stability, while delivering more torque and horsepower. It also helps boost fuel economy, and reduces hydrocarbon emissions. This variable cam phasing technology achieves a balance of response times and torque capacity. The construction of the cam phaser and the oil control valve permits continuously variable control of the intake and exhaust cams.
Thank you for listening.